Smed is a method for analysing and reducing changeover and cycle times, a way of studying the current method and breaking it down into its subparts. It stands for Single Minute Exchange of Dies, which isn't a helpful name. It originally came from someone improving the changeover times of dies, a sort of forging tool. Don't worry about the name. But Smed is a very powerful and important tool. So Smed is about reducing cycle times and changeover times. What is a cycle time? A cycle time is the time it takes a process to do one cycle, the same as processing time. Whereas a changeover time is the time it takes from making one part, then the process has to stop, change over, set up again, until it can start making the next part. So changeover is a sort of downtime. So having shorter cycle times is obviously a good thing. It basically means a faster process. But why are changeovers so important? Well, changeovers are a type of downtime. And if we can do shorter changeovers, it gives us a lot of extra flexibility. It also then allows us to either increase capacity or, the more lean way, to increase the number of changeovers to reduce the lead time, reduce the inventory WIP levels, increase our responsiveness to customers, and this is a business-winning capability. My favourite example of changeovers are Formula One pit stops. Just like many factories, they have a process that must be kept running at top speed. In a factory, it's our bottleneck process that makes all the money. But in Formula One, the only thing that matters is the car going round the track. And whilst the changeover in a factory is when we have to stop the process, set it up for something else, in Formula One, the changeovers are the pit stops, changing the tyres, refueling. There's some wonderful videos on YouTube. If you type in Smed changeovers Formula One 1950s versus today, you'll come up with several wonderful comparisons of how they used to do Formula One pit stops. It wasn't even Formula One back then. No, 60, 70 years ago versus today. I'll just let you search for that. It's a treat. So if the aim of Smed is to reduce changeover times or cycle times, this picture here gives us a good representation. You can see we are making part A, then we have to stop, and the downtime, the changeover downtime begins, and that can take a big chunk of time. In quite often it could be a few hours, until we're ready to start running part B, and then we're back up again. We're going to break down the Smed process of how to go about reducing the time of a changeover or a cycle time into 7 steps. Now, number 1, map the process. This is incredibly important. Take a video of the process. Take a video and then analyze it at slow speed, in slow motion, and write down every step. Ideally, put it into a Gantt chart. Could look something like this. And the Gantt chart lets us visually see all of the different steps in our changeover and how they fit into each other. Step 2. Remove unnecessary activities. Look at every single one of those sub-processes and ask yourself, ask the operators, ask the supervisors, ask the process engineers, do we need to do this step? Ask them, ask that step. You'll be surprised. Step 3, convert internal steps into external steps. This is about moving the activities that are currently done inside the changeover time whilst the machine is stopped, whilst the racing car is stopped, and doing them before the machine is stopped or after the machine is stopped. In Formula One, this is make sure the tyres are ready at the side exactly where you need them. In Formula One, they preheat the tyres so they don't have to be warmed up on the track. They're already warm. They have all their tools laid out. And all this preparation, these are now external steps. They're done before the changeover. So step 3 is to convert internal steps to external steps. Next, we have Do the internal steps, these are the steps that we must do still inside our changeover, do the internal steps simultaneously, in parallel with each other. This reduces the critical path. Now, and only now, should we look at speeding up or shortening the remaining internal processes. This is crucially left until now. We don't try to speed up or improve the programming of the steps first, but only now, after we've tried to eliminate them, do them in parallel, or move them outside of the critical path into external steps. Some ways we could make our steps faster could be through better programming, could be through ergonomic changes, so there's less physical work in moving around. It could be some little engineering redesigns using quick release fixtures or pre-marked settings, etc. Now, we should look at speeding up and shortening the remaining external processes. These are the processes that are no longer even part of the changeover. These are the preparation activities, either before we start the changeover or afterwards. They won't make the changeover shorter, but it will help the changeover operators who may not have the time to do all these external changeover tasks when the process is running otherwise. And finally, do the whole process, all those steps, again. Smed is an iterative process, and the opportunities you saw the first time you went through it will be great, but there will be new opportunities that weren't possible to see back when your process looked so different at the beginning. So, start again, remap the process, and go through those steps. And you could do this several times. The impact is profound. So, now we've been through the Smed process, overall, this could look like this. It's the same picture, but now you can see we show the external processes, both before we start the changeover and after we start the changeover.